And hello everyone, welcome back to another Golang tutorial. So, in the previous tutorial we talked about variables and constants. If you haven't seen those two tutorials, then I do recommend you do, because both of them will be very helpful, especially in future lessons. Let's start off by learning how to do mathematical equations in Go. So here we can say something like var x is equal to, and let's say 10, and let's just specify it's an integer, and var y, also an int, is equal to 7. Now with these we can do a bunch of mathematical stuff. For example, if you print line, usually we could say 10 plus 7, that works perfectly fine as well. Then if we run this, go run dot, this will add the two together, and it actually won't run while these are here, so let me just quickly comment them out. There we go, 17. But we can do the same with variables, so we can replace these with variables like that. Now if we run it, we'll get the same output. Now this is for addition. You also have subtraction, so 10 minus 7, that would be 3. And if we were to increase this to 17, it can go down to the negatives, as you can see right there. Next up, you also have times, but take note, times is an asterisk, because we don't have an actual times symbol on most keyboards. So we use an asterisk, because that's usually on a keyboard. Now if we run this, we'll get 10 times 7, and that is 17. We can also do division. So if we were to say x divided by y, so it's 10 divided by 5, and this uses a forward slash. Take note, a comment is 2 forward slashes, so divide is 1 forward slash. Do not confuse it with the backslash. These two are different. Now if you were to run this, you'll get 2, because 10 divided by 5 is 2. You can also do something like 10 divided by 7, that will work perfectly fine as well. And we'll get 1. The reason we don't get any decimal points are because these are not float. Let's go float through too. Now you'll get whatever else should be here as well. You also have another type of mathematical operation, which is kind of neat in programming. It is called the modulo. So if we use the modulo, 10 modulo 7, we get 3. Now the reason for this is the leftover, basically. So you have 10 minus 7, and that will give you 3. That's basically what it means in a sense. It's not this specific, but that is what it means. If we were to make this 15, you'll notice this doesn't quite work out anymore, because we get 1. So what happens is, when we get this, it will tell us that this is 8. Then it runs it again and goes 8 minus 7. And that gives us 1. Then it runs it again, and it's 1 minus 7. But if we were to minus it again, then it would be less than 0. So it returns this, 1. So it returns anything 0 and up. It's basically what's left over after division. That's a very basic way to explain it, but it's how it works in a sense. You might be wondering, okay, but when is modulo a good thing to use? Let's say you want to know if this value here is an even number. Well, that's simple. Just modulo it by 2. Now you get 1. Because it's 1, that means it's not an even number. Because any even number moduloed by 2 would return 0. For example, if we were to go here and say 4 modulo 2, that will basically go 4 minus 2 is equal to 2. And then it will 2 minus 2 is equal to 0. And because we know we can't go below 0, it will return 0. However, if we do something like 5 minus 2, that will give us 3. And then we have 3 minus 2, and that will give us 1. But we cannot 1 minus 2 because that will give us negative 1. And negative 1 is not allowed, only 0 and up. So if it ends in 1, it is not an even number. If it ends in 0, it is an even number. To show you that this works, if I were to make this 5, we should get 1. If I were to make it 4, we'll get 0. If I were to make this 1920, which is an even number, or let's make it even cooler, 1926, if that is an even number, we'll get 0. But if I were to change this to 9999, then that is not an even number, and we'll get this. As simple as that. One more thing I do want to tell you about is, unlike with other programming languages, with Go, different versions of int does not always work. For example, if I were to say var y is equal to int, or is int 8, and here we can just say 16 or something. Now int 8 is a smaller version of this int here. This int here, I believe, is by default int 32, meaning it is 32-bit. Although don't quote me on that, it might be 64. This int 8 is only 8-bit, meaning it cannot keep nearly as high of a value as this int here. This int can go on for a long time before it runs on a number that is too big. Whilst this can, I think, only go up until maybe 30k, if that much. Now, in other programming languages, you are easily able to add these two together. However, in Go, it's a different story. Saying x plus y, or x minus y, or x divided by y is not allowed. They are taken as two completely different data types. Even if both of them means number, all number, they mean two different data types. So in this scenario, you would want to turn y into int y. This is called type casting. So we are casting int 8 here into a normal integer. And if we run this, it will work perfectly fine. I wonder, does that mean we could go here and say int 8 and pass in this? And then add them together? Yes, it does. However, int 8 cannot take such a large number. So it will give us this, because it starts counting over from the start once it reaches its highest point. For example, an 8-bit integer's max value, I believe, is 256. So just to show you, if we were to then display y here and make it 255, because I'm not sure if it will go up until 256. Actually, here it already tells us it cannot go that high. Unless we probably make this a uint 8, then it will probably be allowed to go that high. Because uint is called an unsigned integer. The difference between signed and unsigned is a signed integer, let's say, can only go from negative 5,000, not really, this number is a lot bigger, but negative 5,000 to 5,000 as an example. Whilst an unsigned integer can go from 0 to 10,000. So it basically doubles the amount it can go by removing the ability to go into the negatives, to go below 0. So I wonder, there we get 255. If I were to make this 256, yeah, it actually really tells me it cannot go that high because it's too high. But in other programming languages, if you do this, it will change back to the lowest value. I wonder, could we go here and say y plus 2? Would that be allowed? And yes, it is. Because the max size of an unsigned int 8 is 255. We say 255 plus 2, 256 is over its highest value, so it starts over. And if we were to remove this uint and just make it int 8, then now it would be 255 divided by 2, about 127. So let's try that. Okay. As you can see, it's limited to 127. But now if we add 2 to it, then we get negative 127. The reason for this is because it starts over. So that's something you should be careful with. However, if you are working with normal integers, then usually you should not be running into this problem here. For example, let's see. When will we get an error from Go? There we go. So to give you an example, this is about the value you can store inside of this integer here without it overflowing. So you don't have to worry about running out if you are using a normal integer. However, a normal integer will use more RAM, more memory to store all of that data than what an int 8 would use. And just like with an integer, an int 8, you can also go uint. And this will, of course, double this. So now if I put a 9 there, it's no longer going to give us a problem. And that's the basics. We kind of went from just doing some adding and subtracting all the way to what an unsigned and assigned integer is. And yeah, thank you all for watching. I hope you all enjoyed. And I will see you all again in the next Golang tutorial.